So the next chapter that we deal with in physics is thermodynamics over here. In this chapter, the key aspect is to interpret graphs. It is very important. So the first question that we have here, we have a graph of pressure versus volume of a gas, and we have been given various paths of going from A to B. You can go to from A to B via the path ACB or via the path ADB. Now for the path ACB, the heat given to the gas is given to be 200 joules. The work done by the gas is given to be 80 joules, and for the path ADB, the heat given to the gas is given to be 144 joules, and we have to find out these things. So let us find them out one by one. So work done along ADB, whenever you've been asked work done, if nothing is mentioned, it means work done by a gas. Even when the work is given, in physics it means work done by the gas if it is not mentioned. So work done along ADB, for the path ADB, we see that for going from A to B via the path ACB and via the path ADB, the change in internal energy of the gas will be same. This is because internal energy is a state function, due to which it will depend only on the initial and the final states. Therefore, the change in internal energy of the gas is constant. Now we know Q is equal to delta U plus W, where Q is the heat given to the gas, delta U is the change in internal energy of the gas, and W is the work done by the gas for any process. So let us write this as Q minus W is equal to delta U. This is true for both the processes ACB and ADB. Now for both ACB and ADB, the initial and final states are same, due to which delta U will be same since it is a state function. Therefore Q minus W for the path ACB will be equal to Q minus W for the path ADB. Now for the path ACB, Q minus W is given to be equal to 120, that is 200 minus 80. This will be equal to Q, that is 144, minus work done by the gas for the path ADB, which we need to find out. Therefore work done by the gas in the path ADB comes out to be equal to 24 joules. So our answer for the first part comes out to be equal to 24 joules. Now let us solve the next part. For the B part, work done on the system along the path BA is given to be 52 joules. We need to find out the heat absorbed by the gas. So for finding out the heat absorbed by the gas on the path BA, we'll again write Q is equal to delta U plus W. Now Q is equal to delta U, that is UA minus UB. This is because the path is from B to A. Therefore the final point is A and the initial state is B. Therefore we write final minus initial. Always whenever there is anything delta P in physics, it is always P final minus P initial. Delta means change in this quantity, that is always final minus initial. So over here we write UA minus UB plus work done by the gas. Now here work done on the system along B is given to be 52 joules. Now work done by the gas is equal to negative of the work done on the system, that is minus 52. So Q is equal to UA minus UB minus 52. So we need to find out UA minus UB. This can be easily found out by using this information, because for the path ACB, we know that Q is equal to delta U plus W. Therefore Q 200 is equal to delta U. Delta U is equal to UB minus UA, because for the path ACB, final state is B, is equal to UB minus UA plus W, that is 80. Therefore UB minus UA becomes 120. So UA minus UB becomes equal to minus 120 minus 52. Therefore Q becomes equal to minus 172 joules. So our answer for the second part, that is the heat absorbed by the system along the path BA, comes out to be equal to minus 172 joules. Let us solve the third part now. For the third part, UA is equal to 40 joules. We need to find out UB. It is pretty simple. We know UB is equal to 120 plus UA, that is equal to 160 joules, because UA is given here to be 40 joules. Therefore this becomes equal to 160 joules. Now for the fourth part, we have been given UD. UD is the internal energy of the gas at the state D, that is given to be equal to 88 joules. We need to find out the heat absorbed by the gas in the path dB. QdB is equal to UB minus UD, that is delta U in this path, because this is the final state now, plus work done by the gas in this path. Now we see that this process occurs at constant volume, therefore the work done by the gas comes out to be equal to 0. Therefore QdB is simply equal to UB minus UD. UB, the value of UB was known to be equal to 160 joules, minus UD, which is given to be 88 joules. Therefore the final answer comes out to be equal to 72 joules. So the answer for this part comes out to be equal to 72 joules. So in this question, we have seen that simply by interpreting the graph and using the simple formula Q is equal to delta U plus W, in which Q stands for the heat given to the gas, delta U is the change in the internal energy of the gas, and W, mind you, is the work done by the gas. So by simply using this formula and interpreting the graph, we get the answer to all the four parts.